Okay, as I said in the previous video, the kernel is kind of the main transaction processor of the Mixin network. So it's responsible for generating the keys, checking various aspects of transactions to make sure they're well formed, coming to a consensus. All these other things are handled by the kernel nodes inside of the Mixin network. So if we go through each of its responsibilities kind of one by one here, we'll see the first one is the ghost output. And what Mixin is doing is it's taking the UTXO model of Bitcoin and mixing it together with the crypto note one-time key derivation algorithm. So what happens is a user will get their public-private key pairs generated, and they kind of walk you through what happens from there when you're generating a transaction for the kernel. In this case, Alice will take Bob's public key and generate ghost addresses from this public key and use these ghost addresses along with some randomly selected UTXOs to send assets from herself to Bob. And the reason they go about transferring assets in this way is mostly for privacy reasons, right? So you have a one-time private key that you can use, and then also you're picking some random UTXOs that you're going to use as the transaction inputs whenever you're sending payment to Bob in this case. They go through all the math here. You can check it out yourself. I'm, for the most part, just going to assume that they've got the cryptography all figured out for keeping transactions private. Again, this course is going to be centered mostly on API style development or like front end full stack development within the Mixin network, and not necessarily the core development of Mixin, right? I'm not teaching you how to be a core developer for Mixin. I'm teaching you how to build dApps on top of Mixin, essentially. So most of this will be abstracted away for us, and we'll just be able to hit an API and say, hey, I want a new public key, which we'll get into all that at a later date. So after we talked about the transaction signing and generating keys and all that stuff, they get into the fact that the kernel is again, it's a set of nodes. In this case, it's a asynchronous Byzantine fault-tolerant graph, and you have to stake. As I said before, Mixin is a proof-of-stake network, so they've set up the incentive to, or the amount that you need to stake to be a kernel node, such that there can be no more than 50 kernel nodes in existence. So these kernel nodes, what they do is they accept transactions. They'll verify the transactions according to these four here, that the inputs are all unspent, that they're valid transactions, essentially, that the signatures are all correct, and that someone isn't double spending or they're not spending more, all the things that you would expect in a UTXO model. Then they'll create what's called a kernel snapshot, and a kernel snapshot is almost like a transaction in most other blockchain-based architecture. It's like the atomic unit for transactions in Mixin. So they'll take these snapshots, and these snapshots are built of the transaction. The previous snapshot's hash are all built into the transaction, and then the node itself will sign the snapshot saying, like, yes, this is indeed a valid transaction. I'm signing it saying that I consider this part of the Mixin network. This transaction, this snapshot, will then be broadcast to, as they say here, B random nodes. Eventually all the nodes will get this, of course, but this snapshot will then be sent to like another node that this node knows about. That node itself will take the snapshot, do the same thing, and continually until eventually the node realizes that 2/3 divided by k nodes have all received the transaction. In this case, k is the 50 nodes that we were talking about before, that there couldn't be any more than 50 kernel nodes, right? So if 2/3 of the nodes have received this transaction, they've all signed it, then it is in fact on the Mixin network. It's a valid transaction, and everybody agrees that it should be in the Mixin network. You can see here they're kind of going through the like recursive snapshot thing that I talked about before, where like A's snapshot and B's snapshot are all included in node. This should probably be node C's version, because node A will have sign the transaction, send it to node B to be included in node B's snapshot. Node B will take a snapshot of both itself and B's snapshot, and then send that to C. C will include all three of them, and inside that transaction, it'll be able to say, okay, 2/3 of the nodes have signed this. I don't need to broadcast this any further. We're going to accept this as a valid transaction. From there, they just talk about more aspects of the proof of stake model associated with it and why it's safe and all that other stuff. One thing they've mentioned throughout the white paper is using a trusted execution environment. It still remains to be seen, right? Because Mixin hasn't been launched. They haven't launched a mainnet yet. So it remains to be seen how often nodes will use this trusted execution environment. It will be interesting to me to see how the TEE gets used, because I'm not that familiar with these, and I'd like to see like how the nodes progress because of that. Another thing they're building into the kernel nodes is a light witness, so you have an SPV similar to what you would have in Bitcoin, where you can sign transactions and keep up with the blockchain and all that stuff without having to be like a full witness to and doing snapshots and all the other things that entail being a kernel node. You won't have to do that because they'll be giving an SPV client. I think that's everything for the kernel nodes. In the next video, we will talk about the domain nodes. See you then.